I'm Nikki and I'm here to explain the 3 ways heat moves at my house. But before I do, I want to wish you all a Merry Christmas and I hope you all had a happy Thanksgiving weekend. I'm going to explain the 3 ways heat moves, and they are conduction, convection, and radiation. The heat from the fire is the radiation, and the water inside as I heat over the fire is convection from when the cold water is going to the bottom so it can be heated, and the water on the top is already hot so it rises, and okay. And then the heat from the fire goes to the metal and that forms conduction so it hurts my hands, and then if we wanted to prevent that, we would put on this glove, which is a good insulator, and if I do the same thing over the fire, it's not going to hurt my hand because it's like keeping the heat away from my hand. In my kitchen, I'm making hot chocolate. When you turn on the stove top is being heated up by radiation, and then the pot that you're cooking the hot chocolate in is heated up by conduction, so don't touch it, if not you're going to get burned. And the hot chocolate inside is being warmed up by convection because the colder part is on the bottom and the warmer part is on the top. Hi, I'm at the fire pit again in my backyard and I found another example. The radiant heat from the fire is moving up to the fan because hot air rises and cold air sinks. So the air is moving the fan because of convection. And my sister is roasting a marshmallow. So the marshmallow is being heated not only by the radiant heat from the fire pit, but the conduction from the metal skewer, which is heating up the inside of the marshmallow. And her hand isn't being burned because the wood is a good insulator to the metal. I'm in my dining room and I am with my cousin Mario Eguis. Say hello.
Hi guys.
Can I ask you a question?
Yeah, of course.
Alright. Name one example of conduction, convection, and radiation.
Okay. Conduction is when, say, you have a candle and you put the candle out with your fingers and you get burned. So that's a physical touch. Convection. So right now I'm going to school in Notre Dame and it's really cold up there. So if you're in my apartment on the first floor, it's really cold. But if you go upstairs, it gets really hot. So convection is basically all the cold air is at the bottom and the hot air is rising to the top. And then radiation, think about being out in the boat or at the beach or something, laying out, and you have the sun heating you up. So basically that heat from the sun radiates radiation.
Hello, I am in my dining room and I'm here with my padrino, Jorgito Rivero. Can I ask a question?
Please.
Your question is, why are metals good conductors of heat?
Metals are good conductors of heat because when metals are heated up, it allows for the atoms to vibrate a lot within, which makes more efficient vibration. And so the more the atoms vibrate, the easier it is for the heat to spread throughout the entire metal.
I'm in the dining room and I'm with my father, Javier Maribona. Hi. Can I ask you a question?
Yes, you can.
True or false? Air is a good conductor of heat.
True. False. False.
Yeah. Hi, I'm in my dining room and I'm with my 2 sisters, Kiki and Caitlin. Caitlin, can you say hi? Say hi. Alright. Kiki and Caitlin, can I ask you guys a question? Sure. Name whether the following events are radiation, conduction, or convection. Okay. The water gets colder as you dive deeper in the water. Convection. Putting an ice cube on your hand. Conduction. The heat from a light bulb on your face. Radiation? Yeah. Slapping. Slapping someone's hand really hard. Conduction. A lava lamp turned on. Convection. And getting sunburned. Radiation. Good. 100. Good job. Can you give me a fist pump? Yeah.